So in this video, we're going to be looking at some of the GCSE higher questions from non-calculator papers. What I suggest you do is look at the question, pause the video, answer it yourself, and then I'm going to model the answer so you can check what you've done. So this is question 6. Here is a rectangle. All measurements are given in centimetres and the area is 48. Show that y equals 3. So pause the video and give it a go. First thing I'm going to do in this question, if I know it's a rectangle, I know that this side and this side are equal. So that tells me that 2x plus 6 is equal to 5x minus 9. And I've formed an equation there. Now in order to solve that equation, okay, I'm going to minus 2x from both sides first. So I'm left with 6 equals 3x minus 9. Now plus 9 to both sides. So I've got 15 equals 3x. And then to solve that, divide both sides by 3, x equals 5. So I've formed and solved an equation, and I know that x equals 5. So I'm going to substitute that back into here. So if x is 5, 2x plus 6, well 2 times 5 is 10, plus 6 is 16. Same here, and just double check to make sure it's right. 5 times 5 is 25, minus the 9 is also 16. So I know that to work out the area of a rectangle, I do base times height. The base is y, and the height is 16, so the area is 16 times y. So if that's 48, 16y is equal to 48. So divide both sides by 16, y equals 48 divided by 16, which is 3. Perfect. We've shown there that y is equal to 3 in this question. Question 2. Pause the video and give this one a go. So Brogan needs to draw the graph of y equals x squared plus 1, so a quadratic curve. Here is her graph. So she's drawn it x squared plus 1. It goes through the right point in the y-axis. Write down one thing wrong with the graph. Well, actually, a quadratic should be a curve. Her graph is not a curve. So that's one thing wrong, or anything to that effect. So you could have said she's used a ruler. She shouldn't have used a ruler. The line shouldn't be straight here. Okay, it shouldn't be. What it should look like is something that goes through all the points, but that's curved at the bottom. Okay. Third question. So again, pause the video, give this one a go. 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. We want the cost of one of each. So I've got here a simultaneous equation. So similar to that first question we went through, we've got to form and solve some equations here. So I'm going to say 3t plus 2c is equal to 780. 5t plus 4c is equal to 1,420. So I've put that into pence. Now there's nothing I can do at the minute because I've got neither of my coefficients for t or c equal. But what I can do, I can make both of them 4c relatively easy. So I can, if I label them 1 and 2, just so you can see what I'm doing, if I do the first equation multiplied by 2, it gets me 4c. So I'd have 6t plus 4c, and that would cost 780 times 2 is 1,560. So I know that 6 teas and 4 coffees will cost £15.60 because all I've done is multiplied everything within that first payment, that first receipt, by 2. So I've now got 2 equations, and I'm just going to rewrite them to make it easier for you to see. You don't need to do this, but I've got 6t plus 4c equals 1,560, and 5t plus 4c equals 1,420. So actually what I've got extra in that first line there is an extra t. So I can do that first equation minus the second one. So 6t minus 5t is t. The coffees will cancel each other out. I've then got 1,560 minus 1,420, which is 140. So I know that a tea costs 140 pence, which is £1.40. So I can write that down here. Now, in order to work out the cost of a coffee, I'm going to just substitute back into this first one. And it wouldn't matter which of the three I substituted into, but 3 teas, so 3 lots of £1.40, plus 2 coffees gives me a total cost of £7.80. Could have kept it in pence, but I haven't. 3 times 140. Well, 3 times £1 is £3. 3 times 40 pence is 120. So I've got £4.20 plus 2c equals 7.80. So I'm going to have to minus the £4.20 from both sides. So 2c is equal to £3.60. And then to work out the cost of one coffee, half that, £1.80. Okay, so what I've done here, I've minus £4.20 from this side to get £3.60, and then divided by 2. Okay, fourth question. So pause the video and give this one a go. Okay, so x is 0.436 and both of those two digits are recurring. That's why those two dots are above just those two. Prove algebraically, that this can be written as 24 over 55. So if I know that x is equal to 0.436 and those 36 are recurring, now I could work out what 10x was relatively easily by multiplying that by 10, 4.36, 36, 36, and so on. Now, that's not going to help me. What I've got to try and do is get rid of or eliminate that recurring part. So, if I multiply the first one by 100 to get 100x, that'll get me 43.6363, and so on. And again, that wouldn't help me. 1000x would get me 436.363636. Now, what I can do is use this equation, this equation here, and this one here, to help me to work this answer out and to prove this algebraically. Because if I did 1000x minus the 10x, I'd be doing 436.363636 minus 4.363636, and that recurring decimal part would disappear. Okay, so that's equal to 436.36 recurring minus 4.36 recurring. Okay, so 1000 minus the 10 gets me 990. 436.36 minus 4.36, well, they will cancel each other out, so I've got 432. Now, to leave x on its own, because I'm proving what x is, x would be equal to 432 over 990. That doesn't look like the value in the question, so I'm going to try and simplify it. So I'm going to half both of them, just to make it easier. So I've got 216 divided by or over 495. So at this point, I've got to try and work out what's both of these are divisible by. So what's a factor of 216 and 495? So actually 2 add 1 add 6 is 9. 4 add 9 add 5 is 18. Because both of those are divisible by 9, then 9 is a factor of both of these. So I can divide both of them by 9. So 216 divided by 9, 0, 2, carry the 3, so 4, 24. And then 495 divided by 9, 9's into 4, 9's into 49, well, 5, carry the 4, 9's into 45 again is 5, so I've got 24 over 55, which is what the question's giving me.